Okay, most books talk about the trial and error method of factoring. Factoring is the opposite of foiling. Foiling is F-O-I-L, where you do first times first, outside times outside, inside times inside, and last times last. Then you get a trinomial. Well, this is going in the reverse, and it's trying to go back to the original. And you would say, what multiplies by itself to give you 3p squared? That would be 3p and p. I'm doing guess and check right now. This is called guess and check. Okay, let me minimize this. Okay, and then what multiplies up to 5? So if I said 5 and 1, then you just do guess and check. That would be 1p, that would be 15p, and that would not give you 2. So I would have to get my eraser out, and I would have to switch them. I would put 5 in the first parentheses. This is called trial and error. And 1 in this, and this would become 5p. That would be 3p. And if I tweak the signs to make this negative and this positive, then I would get back to the trinomial. And so my answer would be parentheses 3p minus 5 times p plus 1. Trial and error method. The method that I'm going to talk about today is a method that takes out the trial and error, and you get the right answer every time. So I'm going to do a good portion of this worksheet with you. Starting with number 2, I'm going to teach you the technique. Now, the reason we call it the Lizzie technique is because a girl named Elizabeth at a different school district figured this out, so we give it her nickname. Okay, so this is the first thing you're going to do. You're going to do front times back, and you're going to write it over here. You're going to do the first coefficient times the number at the end of the trinomial. And you're going to write over here with the sign. And then you're going to list all the things that multiply up to 18. So you have 1 and 18, 2 and 9, 3 and 6. And then you're looking for a combination that you can get a 3 out of. So 1 and 18 would give you either 19 or 17, so that's not going to work. But 3 and 6 would. So you circle the winning combination, and then you have to affix the signs so you will get a positive 3 when you put them together. So because it's a positive middle term, you're going to want the bigger number to be positive and the smaller number to be negative, like that. So my winning combination is negative 3 and plus 6. You're going to put that in parentheses, but you're going to do it this way. You're going to do n minus a little 3 in a numerator like that, and n plus a little 6 like that every time. You're going to put it in like it's in the numerator of a fraction. And then whatever is in the front here goes in the denominator of both of those, like that. Then you're either going to reduce, if you can. So for example, this turns into n plus 3 because 2 goes into 6 3 times. This one does not reduce, so you're going to do something called slide the 2 in front like that. You're going to take whatever's in the denominator, you're going to slide it in front. So that's going to become 2n minus 3. So your answer is 2n minus 3 times n plus 3. And that is the correct answer the first time, every time, and it takes out the guess and check. And we're going to do a lot of them. We're going to do a lot of them. I don't know how she figured it out. I don't know. She was a very bright girl. I didn't follow her life, but anyway, let's. It would be interesting to find out what she ended up going to school for. She was obviously very bright because she came up with this by herself. So let's just keep going on. Now, there's a couple of I don't know. There's a couple of conditions. There's a couple of conditions to this. The first thing is, if you can take something out first, you have to. So you do have to check, is there anything that comes out of 3 and 8 and 4, yes or no? No, not in this case, but you have to check that or you're going to run into problems later on. So nothing can factor out. So you can either do it trial or error, or you can do it this way. You do first times last, and you put it up here with the sign as positive 3 times positive 4. and that gives you a positive 12. And then you list the factors of 12, and you circle the combination that you can get the middle term of the trinomial. So that would be what? That will give you 7, but 2 and 6 will give you 8. But notice it's a negative 8. So these numbers have to have a sign, so they add to negative 8, but they multiply to positive 12. They both have to have the same sign if they're going to multiply to a plus 12. Do you remember the next step? You put it in parentheses, but you make them tiny. So it's going to be n minus a little 2 and n minus a little 6. Because I'm going to divide those both by 3, which is in the front of the trinomial, the leading coefficient. Then you're going to divide those both by 3, and then you're going to reduce if possible. This one can't reduce, so you're going to slide the 3 in front. This one can reduce. 3 goes into 6 twice. This is your answer. Okay. Now, with trinomials that have a 1 here, you can still do it if there's a 1 in front. It's just sometimes it's quicker to think about it in your head. But this does work, even if your coefficient is 1 or greater than 1. Okay, moving ahead, I'm going to go into progressively more difficult ones as we go. So just keep up with me. Okay, we are on 4. Okay, now this is a good one for me to show you another trick. First of all, can anything come out of 5, 19, and 12 that's common factor? No. So what do? You do front times back. What does 5 times 12 equal? Now that has a whole lot of factors. So this is where you're going to need your graphing calculator. Pull up your graphing calculator like so. Now you're going to go to y equals, and you're going to do 60 divided by x. Now you're going to want your table to start at 1 for this. So go to second window, and make sure it starts at 1 and you're going up by 1. Then to get to your table, you do second graph. And there's the factors of 60. You ignore the decimals. So you got 1 times 60, 2 times 30, 3 times 20. And when you go further down, it's going to start to repeat. So I'm going to grab the ones that don't repeat. See if it will let me do this. I'll try. Okay, so here's my factors of 60. Now what kind of combination am I looking for? It has to multiply to a plus 60 and add up to a positive 19. Do you see it? Right there, 4 and 15. So you're going, and they're both going to be plus, right? So you put that in parentheses, but make them small. So it's going to be n plus a little 4 and n plus a little 15. What do I do? What do I divide it by? My leading coefficient, which is 5. If you can reduce it, go ahead, and then you slide what you're stuck with. So this is going to turn into 5n plus 4, and this is going to be n plus 3. And it doesn't matter the order. You could do n plus 3 first if you wanted to. Multiplication doesn't matter the order. So that's a helpful hint with your graphing calculator, especially if you have a large number with a whole lot of factors. That helps to put it into your y equals. Okay, let's keep going because I know there's some more difficult ones on this sheet. Okay, see if you can do 5 without me. I'll give you a minute. Yes. Okay, so it's front times back. Change to marker. That's going to be 10, and you can tell it's going to be 1 and 10. That's plus, plus. That will give you the 11. So it's v plus a little 1 times v plus 10. And you're going to divide those both by 2. So this is 2v plus 1 times v plus 5. Okay so far? Everyone okay with this so far? All right, let's pick something harder then. I'm going to start jumping around and picking something that's harder. 7, okay, I will do 7. That will be fine. Now, the first thing you have to ask yourself, is there something you can pull out of 7, 53, and 28? What? I think 53 is prime. I don't think you can, but you need to check just in case. You do need to check, but no, you could divide 53 divided by 7. I'm pretty sure that's not going to work. Yeah, so that's not work. So once you've checked that, then you do front times back. So what is 7 times 28? Anyone? 196. What's my sign? Positive. So you go to your calculator and you do 196, go to y equals. So 196 divided by x. And pull that up, second graph. So there's all my factors. What am I looking for? 53. I need a combination that will give me 53. So 4 and 49 would work, right? Okay, so 4 and 49 is your winning, and they're both going to be plus to give you a positive. So you're going to put those into the parentheses. Oopsie daisy. Hold on. I keep losing stuff here. Sorry. Here we go. So you're going to put this in the parentheses like this. What was it for? A plus a little 4 and 49. Divide by what? 7. Divide by your leading coefficient. Okay, so that's going to slide and become 7a plus 4. And this is going to be a plus 7. And you're done. Okay, we still have to go to a harder one after that. Still same technique that we did before. Graphing calculator helps a lot. Okay. Nice thing is it takes out the guess and check. Like I said, this one kid, he swore by this in his college algebra class. He said this helped him so much, and he did pull an A. Okay, now, this one, you can pull something out. But what's going to happen is on a test, someone's going to forget about it. And I'm going to show you what the problem is if you forget about it. So what comes out of 9 and 66 and 21? 3 can go into all of those. So let's pull out a 3 first. So you do 3 parentheses 3k squared plus 22k plus 7. That's important that you do that step and do not neglect that step. Then you're going to put your hand over the 3 and you're going to ignore it for now. And when you do the front times the back, it's going to be within the parentheses. So I get 21. And then it's going to be obviously 1 and 21. That's what's going to multiply to 21 but add up to 22. So you keep your 3 in front like that, and you break it down again like that. And you're going to do k plus a little 1. And you're going to do k plus a little 21. And you're going to divide by what's in the parentheses. You divide by your new leading coefficient, not by 9, but by 3 now. Okay, now this turns into 3 from what we pulled out at the beginning, times 3k plus 1 times k plus 7. This is the correct answer. Now, how do I know? I could FOIL that. I could multiply these two binomials, lattice or foiling. Then I would distribute the 3 back in, and I would get back to the original. But you need to watch this. Even if you don't write it down, watch. I'm going to do what a lot of kids do on a test or quiz. Guess what they forget to do first? They forget to pull something out. So let's go that route and see what happens, okay? Somebody do 9 times 21 for me. 189. So then I would be going into my calculator and I would do 189 divided by x. And then I would pull up my table. And I'm looking for a combination that gives me 66. Yeah, 3 and 63 would work, right? I would keep scrolling down. It would have to be in there. It would have to be in there. Okay, unless it's not factorable, in which case you use the quadratic formula. Okay, so it's 3 and 63. Keep watching. So I'm going to do this. Got to go back to my marker. K plus 3 over, and then K plus 60. What was it? 3? Okay, yeah. Divide by 9, divide by 9. Now, I always tell you to reduce here, right? So what does 3 over 9 reduce to? 1/3, 1 over 3, 1 over 3. So that's K plus 1/3, which you're still going to have to slide after you reduce it, because that's not in lowest terms. And then you're going to get K plus 7. And then this will slide, and I get 3K plus 1 times K plus 7. Now, what's the matter with my answer? If I FOIL that back, it will not get me back to this. What's missing? The 3 in front. Remember we pulled the 3 in front out last time, and we had a 3 here? So this is incorrect. So my point is this. Always pull something out first, if possible. Always pull something out in front first. Okay? Because you got to have that 3 in front. See, here's the real answer here. That was the one where we pulled the 3 out first. So you've got to look for that before you do anything. Pull out the 3, carry it through, then you get the complete correct answer. When I didn't pull out the 3 and I reduced, it disappeared. So that's one of the glitches. Okay, so let's see if there's anything else tricky. Is 9 tricky? Okay, let's do 9. What are you supposed to check for first? If anything can come out of 15, 27, and 6. 3 can, so do that first. Pull out the 3. Then you ignore the 3 for now. It does have to show up in your final answer. And you do the front times the back here, which is negative 10. And then you ask yourself what multiplies to a negative 10 but adds up to a negative 9. Plus 1 minus 10. The signs have to work, both for the multiplication and for the addition. And then you put that in the parentheses. Don't forget to leave the 3 in front. And it's going to be n plus a little 1 and n minus a little 10. And you're going to divide by 5 now. That's what's in the parentheses. And so your answer is 3 times 5n plus 1 times n minus 2. And if I were to multiply this back out, I should get back to the original trinomial. This only works with quadratic trinomials. If there's 4 terms, you go the grouping route. This is 3 terms. This is a trinomial. It's quadratic. You can't use it if it's cubic. You got to get it down to quadratic before you can use it. Now, there was a teacher who was here. She's now not here. She came up with a rhyme to help her students remember the technique. A times C adds up to B divide by A and you're on your way. A times C adds up to B, divide by A, and you're on your way. And she told it to her kids so they could memorize it. Because, again, you're not going to find this in a book. A times C adds up to B, divide by A. Then reduce or slide. So that's just a little helpful device for memorizing this when someone is not around to remind you what the procedure was. Okay, let's see if there's anything more difficult on this sheet. Anyone have another request? How about 12? Okay, let's do 12, and then I'm going to jump to the next page, which has perfect square trinomials on it. Okay, so 4 times 49, because I don't think there's anything that comes out of 4 and 35 and 49. So you do have to check. So 4 times 49. What was it? I did it wrong. What was it? 196, and it's going to be a positive, yes. Okay, so let me put that into my calculator. 196 divided by x. Call up my table. Let's see if I can take a picture of this. Give me a second. So I have 7, 8. I don't know if what's down below. I'm just going to take a picture of this one. Give me a second. Let's see. So what do I want it to add up to? Okay, so do we see it yet? 7 and 28. Okay. So 7 and 28. What are your signs going to have to be? They both have to be the same because they multiply to a positive. Okay, so that's just going to be x minus 7 over, then x minus 28 over, and then divide by a. That was a times c adds up to b, divide by a. Okay, that was not hard. That was easy. That was easy. There was another one. Let's see if I can find it that we did earlier today. If I can find it. It had some possible confusion. Oh, let's jump to 16 so I can show you what to do with 16. Okay, if you notice for 16, notice how they're all negatives? You need to pull out a -1. You need to pull that -1 out in front. I don't think I think that's the only thing you can pull out. And that's going to turn to plus 25a and plus 25. Everything's going to flip over its signs. And then you do a times c from here to here. You leave the -1 out in front. Okay, so it's 6 times 25. So it gives me 150. I'm going to go ahead and put that into my calculator. It's positive 150. So I go to y equals 150 divided by x. Call up my table. And I'm looking for a combination of 25. Do you guys see it? Okay, look. Okay. So do you see 30 and 5? Okay, watch. There's a problem with 5 and 30. There is an issue with it. I need a plus 25. So how do I get that? But multiply those. Yeah. It doesn't multiply to positive 150. So you have to throw that out. It has to match with the signs as well as with the numbers. So you got to keep going down your list in your calculator till you find something that does work. That was kind of tricky. It was deceiving. It seemed like it would work because it added up to positive 25, but it did not multiply to negative 150. So you got to throw it away and you got to go back. We got to find something else. So I'm going to scroll down. Keep going. There it is. Positive 10 and positive 15. So you got to double check your signs. So 10 and 15 plus plus. Now it works out both ways. It adds up to 25 positive. It multiplies to positive 150. So it's going to be a plus 10 over an a plus 15. Don't forget you have the -1 still out in front. Divide by a, which is positive 6. I would put those in lowest terms. So 10 over 6, those are both even, so you can cut those both in half. So it's going to be 5/3. And this is going to be 3 goes into 15 5 times, and 3 goes into 6 twice. Don't forget you have the -1 in front. Now go ahead and slide your denominators in front. So your final answer is -1 times 3a plus 5 times 2a plus 5. You are done. So those are some of the glitches that you have to watch out for when you're using this technique. You need to pull out what you can first. You have to make sure your signs match when you find something. Yes? Because if we don't, let me just pause it for a second. Are there any other requests before I go to the next sheet? Okay. Now, the next sheet is perfect squares. These are perfect squares. Okay. We talked about perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, and so on. Okay? And we said that there was a pattern with perfect squares. I told you this a long time ago. Remember I said that if you had x squared minus 25, that's x plus 5, x minus 5. Remember that? This was something I told you last week. And if I said you had 81x squared minus 100, what would that break down to? Can you tell me? 9x and 9x. That's the square root of the first one. What's the square root of 100? 10 and 10. And because the middle term is missing, what do we know about the signs? Plus and minus. This is a squared minus b squared equals a plus b. They expect you to remember this from a prior math course. It's the pattern of the difference of perfect squares. But, so if I come to here, notice 16 is on my perfect square list. And 9 is on my perfect square list. If I were to break it down, what would it break down to? You do parenthesis, 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 parenthesis. Now, this is how I highly recommend you doing it, is to memorize the perfect square pattern. I recommend it. You can use the Lizzie method on this, but it's going to take more time. I'm going to show you in a minute. So I recommend you train yourself to do this first. What's the square root of 16n squared? What times itself gives you 16 and 4n and 4n. So the square root of the first term goes in the front part of the parentheses. The square root of the second term, which is 9, what's the square root of 9? That goes here and here. And the pattern is, because the O and the I and the foiling cancel each other out, we know that this is plus and this is minus. That is your answer. That's correct. It's easier than doing Lizzie, but I'm going to show you the Lizzie anyway, just because somebody wanted to know if you could use it. Give me a second. Okay, so you would do it this way. You would do 16n squared plus 0n minus 9. You'd have to put the 0 in if you wanted to do the other technique. Then you would do 16 times 9 negative. It's going to give you a negative 144. And then you would realize that plus 12 and minus 12 would have to be the combination that multiplies up to negative 144 but adds up to 0. And so you would do n plus a little 12, n minus a little 12, divide by 16, divide by 16, but that's not in lowest terms. 4 goes into 12 and 4 goes into 16. 4 goes into 12, 3 over 4 here. And this is again going to be n minus 3 over 4. And then you have to slide. You still get the same answer. But it's easier if you just know the pattern of take the square root, plus and minus. It's easier. Okay, so you have to practice. They recommend you memorize the perfect square patterns. So just a couple of more. Okay, this is similar, but it's not exactly the difference of two perfect squares. All right, you can do the Lizzie method, but it's the long road. That's the long road. So I don't want you to take the long road when there's an easier way. So I notice that this is a perfect square. This is a perfect square. So let's try to take the shortcut of perfect squares. What's the square root of that? 4b. What's the square root of that? What will my signs be? No, because then it would be poof, it would disappear. If you had plus and minus, poof, it would disappear. This did not disappear. So guess what? If the middle term's negative, you do this. Negative, negative. That's, again, from a long time ago. You were taught that back, I don't know, a year or two ago. But I'm just rehearsing it right now. Okay, now, do the little check. What's this times this? Negative 20b. What's this times this? Do those add up to, yes, so this is correct. Now that's quicker than doing the whole A times C adds up to B divided by A. That's quicker because it's perfect square. As a matter of fact, everything on the second sheet are perfect squares. To train you to look for perfect squares, because I don't want you using the Lizzie technique if it's a perfect square, because that's the harder of the two techniques. Sometimes it's the easier thing to do, sometimes it's the longer thing to do. So you need to recognize that perfect square list is 1, 4, 9, 16. So let's look at 5. 5 is a piece of cake now that you see it. Perfect square in front, perfect square in back, parenthesis, 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 take the square root, take the square root. 3x, 3x, 1, 1. Plus and minus, you're done. So don't forget to look for patterns too. Now I want to go down and see if there's something harder on this sheet. Okay, look at 12. No, let's do 11. 11's a trick. What's the glitch with 11? What do you see? A hint, they're both even. So immediately you know that they both can, you could take a 2 out. Can 4 come out of 98? I have no clue. Let's do this. 98 divided by 4. No, no. So 2 is the highest thing. So when you take 2 out, that gives you, what's half of 98? Anyone know? What's half of 200? 200? 100. Now look at what's left behind. Aren't those both on the list of perfect squares? So you keep the 2 out front, then you break it down like that. You take the square root of the first term and put it in the front of both of those parentheses. Take the square root of 100, put it in the back of both parentheses. And then it has to be, there's no middle term, that would be a 0, so that has to be plus and minus to make those be perfect. But don't forget the 2 in front that we pulled out. So you still had to pull something out first. That will always be your first step, no matter what kind of problem it is. And then if you have perfect squares, go the shortcut route. If you don't, if you've got a regular trinomial, then you can do the Lizzie method. But now you have some tools in your belt for tackling complicated factoring problems. And so I wanted to take an entire day out to teach you this, to let you practice it. So when we go back to the next assignment on Wednesday, I'm going to be reminding you, use the Lizzie method, use the perfect square technique, because we're going to have to start doing more complicated polynomial factoring. I will put this on my webpage. I'm going to put it under Lizzie/factoring so you know to recognize it.